Section 5.2 is on our probability rules. Today is the first day that we're covering Section 5.2. And after this section, you should be able to describe chance behavior with a probability model and define and apply the basic rules of probability. In Section 5.1, we use simulation to imitate chance behavior. Fortunately, we don't have to always rely on simulations to determine the probability of a particular outcome. When we have a description of chance behavior, it contains two different parts. The sample space, which we label as S, of a chance process is the set of all possible outcomes. For example, if I'm flipping a coin, I would have two possible outcomes. I could either get a head or a tail. So heads and tails are my sample space. A probability model is a description of some chance process that consists of two parts. The sample space, which is S, and a probability for each outcome. So for the coin example, the probability of getting a head would be 0.5, and the probability of getting a tail would be 0.5. Here's another example of rolling a pair of dice. Give a probability model for the chance process of rolling two fair six-sided die. One is red and one is green. Here would be what our sample space would be. There are 36 potential outcomes. Since the dice are fair, each outcome is equally likely, meaning each outcome would have a 1 in 36 chance of occurring. Probability models allow us to find the probability of any collection of outcomes. An event is any collection of outcomes from some chance process. That is, an event is a subset of the sample space. Events are usually designated by capital letters like A, B, C, and so on. If event A is what you're dealing with, we would write the probability of A as occurring as P of A. In the dice example, suppose we define event A as the sum of a 5. There are 4 different chances of ending up with the sum of a 5. Since each outcome has a probability of 1 in 36 of occurring, the probability of event A, which again was the sum of a 5 occurring, is 4/36. Suppose event B is defined as the sum is not of 5. What would be the probability of B? Well, there's 2 ways to calculate this. One is you could just count up how many outcomes would not be a 5 and then put that number over 36. Or since we already know that the sum of 5 is 4 out of 36, we could subtract 4 over 36 from 1, leaving us with 32 out of 36. This will be one of our rules. It will actually be our complement rule. Here are some of the basic rules of probability. All probability models must obey the following rules. Number 1, the probability of any event is a number between 0 and 1. We are not going to deal with percentages now. We're going to deal with proportions, so get used to dealing with decimals. Number 2, all possible outcomes together must have a probability whose sum is 1. There can't be anything left out from your sample space. If you add all your probabilities together, the sum of all those probabilities of all possible outcomes must equal 1. Number 3, if all outcomes in the sample space are equally likely to occur, the probability that event A occurs can be found using this formula. The probability of A will equal the number of outcomes corresponding to event A divided by the total number of outcomes in the sample space. Not all probability models are all outcomes equally likely, so this is a limited formula. Number 4, the probability that an event does not occur is 1 minus the probability that the event does occur, and that is called a complement. 2 complements must add up to 1. Number 5, if 2 events have no outcomes in common, the probability that one or the other occurs is the sum of their individual probabilities. When you have 2 events that do not have any outcomes in common, they are often referred to as mutually exclusive or disjoint. 2 events are mutually exclusive if they do not have any common outcomes. so they can never occur at the same time. In terms of notation, here are what our rules look like. You can see the first one: for any event A, 0 must be less than or equal to the probability of A is less than or equal to 1. Again, the probability of any event must be between 0 and 1. The second one: if S is the sample space in the probability model, the probability of the sample space is equal to 1. That means all the samples added together must equal 1. Third one: in the case of equally likely outcomes, there's your formula. The probability of A will equal the number of outcomes corresponding to event A divided by the total number of outcomes in the sample space. Here's the complement rule. Again, the complement rule is the opposite of something else occurring, and that is read: the probability of A complement is equal to 1 minus the probability of A. And the last rule here is the addition rule for mutually exclusive events. There is a more complicated rule for addition if the events are not mutually exclusive. But as of right now, this is what we're covering. And if A and B do not have any outcomes in common, the probability of A or B occurring is just the probability of A plus the probability of B. Distance learning courses are rapidly gaining popularity among college students. Randomly select an undergraduate student who is taking distance learning courses for credit and record the student's age. Here is a probability model. You can see my age groups are grouped between 18 and 23, 24 to 29, 30 to 39, and 40 and over. A, I want to show that this is a legitimate probability model. And B, I want to find the probability that a chosen student is not in the traditional college age group between 18 and 23 years old. First, remember to show a legitimate probability model. All probabilities in the model must be between 0 and 1, which is the case here. They range from 0.12 up to 0.57. And also the sum of the probabilities in the sample space must add up to 1. So if I add 0.57, 0.17, 0.14, and 0.12, the sum must equal 1. And in this case, it does. B, find the probability that a chosen student is not in the traditional group of 18 to 23 years old. In this case, I'm trying to find the complement of the 18 to 23. So my complement rule again is 1 minus the probability that that event does happen. So in this case, it would be 1 minus the probability that the student is between 18 and 23 years old, which is 0.57. When I take 1 minus 0.57, I end up with 0.43. So the probability that it's not the traditional age student is 0.43. This is the end of section 5.2, day 1